Okay, last thing we have to do with rational functions is write the equations, but hopefully with all the work that you've done with finding the asymptotes, intercepts, and holes, then you should be able to read these and kind of understand what's happening, and that's the approach that we're going to take. So when we're writing a possible rational function, that means there are multiple ways this could be written. Remember that rational function means you're looking to write a polynomial in the numerator and the denominator. So first piece of information is that there's an asymptote at x equals -3. That's a vertical asymptote. Remember where we got our vertical asymptotes. To find our vertical asymptote in an equation, we usually took the denominator and set it equal to 0. So if I kind of work backwards, they got x equals -3. If I move the 3 back over by the x, it looked like this. That means they must have had x plus 3 as a factor in the denominator. Y equals to 0, since it's y equals, that's a horizontal asymptote. Remember, this tells us the degree of the denominator is larger. I'm not going to fix that yet because I want to wait and see what else goes into the equation that might change the degree. And then at the end, I'll check if that requirement is met. And if it's not, I'll make sure that it's met. And then the last piece of information is that the x-intercept is at 2. Remember how you guys found the x-intercept? I'm just going to write kind of a summary here. You set the y equal to 0, and you had the numerator and denominator, and then you multiplied both sides by that denominator. This part stayed 0. So you had 0 equal to the numerator. So the way that they're getting an x-intercept of 2, if we work backwards and move the 2 back over by x, is by setting x minus 2 equal to 0. That meant that in the numerator, they must have had an x minus 2. So that will give me the numerator. So that's all the info. So I'm going to go back and check this horizontal asymptote information. The degree of the denominator is larger. So in this case, it's not. Right now, they both have a degree of 1. I can easily fix that either by putting in extra stuff or just by squaring that factor there. And this is a possible rational function that meets the requirements listed. So one more example of this. Same thing, we're going to write a possible rational function. So we're talking about the fraction form with polynomial top and bottom. It says a whole at x equals -1. So remember how we got a whole? To have a whole, we had to have an equation where we had some factor that was the same that got canceled out. So this means there must have been a similar factor, numerator and denominator. For the x value of the whole to be -1, if we work backwards, move the 1 back over to the same side with x, we must have set x plus 1 equal to 0, which means x plus 1 must have been what was in the factor that was canceled out. An asymptote of x equals x equals 4 is our vertical asymptote. Again, remember, that came from, let me write it like this, the denominator set equal to 0. So I must have set x minus 4 equal to 0. So in my denominator, I must have something like x minus 4. The y equals 3 over 2 would be our horizontal asymptote. And the fact that it's a number but it's not 0 means that we have to have the same degree in the numerator and denominator. Like if this one's a squared, then this one's a squared. And that this one must have had a 3 and a 2, and that's how they got that asymptote. I'm not going to fix that right now. I'm going to finish and then come back and check that. And then lastly, an x-intercept at 5. Just going to kind of refer back to what we talked about here. That means it must have come from the numerator. So they set something equal to 0 and solved and got x equals 5. If we work back from that, it must have been x minus 5 equal to 0, and it must have been in the numerator. All right, so now I put all the numerical info in there. I'm going to come back to this horizontal. First, do I have the same degree? And the answer to that is yes. If I multiplied out my numerator, I'd have an x squared, and I'd have the same in my denominator. But I need these lead coefficients of 3 and 2. So honestly, I'm just going to make a 3 multiply everything here and a 2 here. And that would give me 3x squared in the numerator and 2x squared in the denominator. So that is one possible way to write this. This is the last thing. So really this week, this is a small piece of information. And some of you could have done this without the lesson. So just keep in mind that really the goal for this week is review. You guys should come prepared to our Google Meet with some good questions that I can answer for you. I'm going to try and post some stuff in the discussion as well. I really want you guys to make sure that you're getting prepared for our test.